let's see mechanical waves. What basically waves are? In waves, you're transferring energy from one place to another. And when you transfer this energy, medium particles, you do not displace them effectively. Look at this system. If I transfer energy from this hand to this hand by throwing this marker, if I throw this marker, I have transferred energy from this hand to this hand, the kinetic energy of the marker. But in this, what is happening? I have moved the entire marker from one position to another. This is not called wave. Wave is defined in this form. Let's say we have several markers placed side by side. They are placed side by side, and if I move the leftmost marker, then its push is transferred from this side to this side, and ultimately the marker which I've got in my hand will also get some energy. This type of energy transfer, where effectively medium particles, they do not change their position, is called wave propagation. Now, when I say effectively, it means you have to move this marker. Imagine the whole setup in this form. You've got several simple pendulums, and if you displace one of these, then it's going to oscillate. But effectively, it is at this position only. It doesn't move from this position to this position. It simply oscillates about this position. So when you have these pendulums connected like this, you displace the blue one. When you displace the blue one, it will also displace the black one. Now, this transfer will take place from one position to another, and all these medium particles, they will simply oscillate about their respective positions. Effectively, their mean positions will not move. This type of energy transfer from one place to another is called wave propagation. Write down the statement. When energy is transferred from one place to another without effectively displacing medium particles, then this type of energy transfer is called wave propagation. This type of energy transfer is called wave propagation. Write down the statement. Write down the next statement. Waves are defined in following ways. Waves are defined in following ways. First is based on the requirement of medium. Based on the requirement of medium. Now, what is the meaning of requirement of medium? In this first type, first part is mechanical waves, which we are basically interested in 11th. Now, what are mechanical waves? For mechanical waves, you need medium particles. If medium is not present, mechanical waves, they will not be present. What is a mechanical wave? Sound. Sound needs what? Air or gas or any medium. If air molecules are not present, if air molecules are not present, they will not oscillate, and if they do not oscillate, no energy transfer will take place. When I transfer energy from this hand to this hand by moving these markers, if markers are not present, there is no way I can transfer energy from this hand to this hand. So when you need to have a medium, presence of medium, then the wave which you get is called mechanical wave. Write down the statement with mechanical waves. When energy transfer between 2 points, needs presence of medium, then this type of wave is called a mechanical wave. For example, sound waves. Waves produced in a string. Suppose you have a string, a rope. If you have a rope and you produce vibrations in this string, then waves will be traveling along the length of the rope. But if string is not present, there is no mechanical wave which you will see in that string, because there is no string in fact. So point is that for mechanical waves you must have some medium. Second type of the requirement part is non-mechanical wave. What is a non-mechanical wave? For a non-mechanical wave, you do not have to have any medium. You can transfer energy from one place to another without any medium present between 2 points. For example, when you transfer energy, when energy comes from sun to earth, there is no medium present in between. It's entirely vacuum, but still we get sunlight from sun to earth. So this type of wave propagation is called what? A non-mechanical wave. Write down the statement. When energy transfer between 2 points, does not require any medium, then this type of wave is called a non-mechanical wave. For example, light rays, X-rays, gamma rays, or any electromagnetic radiation. All the electromagnetic waves, they are basically what? Non-mechanical waves. You will see these non-mechanical waves in 12th. In 11th, we are basically interested in the mechanical waves part. Now this was the classification which is based on the requirement of medium. If you need a medium or you don't need a medium. The second classification is based on the type of oscillations. Now, type of oscillation means we get transverse waves. Now, what are transverse waves? If you take a string and move one of the end in this direction like this. When you move this end in this direction, you see that a wave is being formed. Energy is transferred from this side to this side, let's say along the x-axis. But medium particles of the rope, they are oscillating in this direction, let's say along the y-axis. When oscillations, they take place perpendicular to the direction of propagation, then that type of wave is called a transverse wave. Write down the statement. When oscillations take place, perpendicular to the direction of wave propagation, then this type of wave is called a transverse wave. For example, waves produced in a rope. Next example is non-mechanical waves or electromagnetic waves. Write down the second example, electromagnetic waves. Now, in electromagnetic waves, there is no medium present, and therefore you don't see any particles oscillating. What happens in non-mechanical waves like electromagnetic waves, electric field and magnetic fields, they are oscillating. How do they oscillate? What are electric fields and magnetic fields? You have a little bit of idea of that, and we will see all these things in detail in 12th. As of now, you just remember that transverse wave. What are the examples of transverse wave? You have a rope and you produce disturbance in the rope. Then this disturbance moves in this direction, but all the particles of rope, they are oscillating in this direction. When you have light, if light is traveling along the x-axis, then electric field, it oscillates along y-axis, and magnetic field, it oscillates along z-axis. We'll see that in 12th. Write down the second type. Second type is longitudinal wave. Now, what are longitudinal waves? Write down the statement, if medium particles oscillate in the direction of wave propagation, then this type of wave is called a longitudinal wave. For example, sound waves. In sound, what happens when you say something? All these air molecules, they oscillate like this. Sound is traveling in this direction. Molecules, they are also oscillating in this direction, and therefore it's called what? A longitudinal wave. Suppose you have a spring. If you have a spring like this, and you push this end in this direction, then the compression part, it will also travel along the length. In a spring, a wave which you create is an example of longitudinal wave. If you push this thing, the compression, it will travel along the length of the spring, and therefore this is another example of longitudinal wave. Write down the example. A compression sent in a string travels along its length, and therefore is an example of longitudinal wave. Now comes the third type. What is the third type? Third type is based on the way of propagation. Based on the way of propagation. What is way of propagation? You will understand it with the help of examples. If you have a rope, then you know that in a rope, disturbance or energy transfer, information which you send from one place to another will take place along the length of the rope. If you say wave can travel only along the length, then what type of wave do you see? One-dimensional wave. This is the meaning of the way propagation wave propagates from one place to another. Write down this third type, and in third type write down the first part, one-dimensional wave. One-dimensional waves. If wave propagation takes place in a straight line, then this type of wave is called a one-dimensional wave. Then this type of wave is called a one-dimensional wave. For example, waves produced in a string. Waves produced in a string. Inside the bracket, transverse wave. Another example, waves produced in a string. Waves produced in a string, longitudinal waves. Inside the bracket, longitudinal waves. It's a one-dimensional wave. The compression which you produce is going to travel in this direction, 1D. When you have a rope, you're oscillating things in this direction. These are the oscillations. We're not interested in this part. We are interested in the way information propagates. Information can only travel along the length, and therefore this is what a one-dimensional wave. We'll understand 1D when I explain 2D. Write down second type, two-dimensional waves. Two-dimensional waves. When a wave travels in a plane, then it is called a two-dimensional wave. Now think of an example of two-dimensional wave. When you throw a stone in water, the ripples which you see, the waves which you see, they only lie on the surface of water. They are only traveling along the surface of water. And therefore, surface is what? Two-dimensional thing, which is this second type. Write down the example. For example, waves produced on the surface of water. Waves produced on the surface of water. And remember, I'm saying waves produced on the surface of water. If you are inside water, we produce longitudinal waves. If somebody goes inside water and says something, that is sound. What is sound? Longitudinal wave. and you throw a stone on the surface, then the wave propagation which you see is what? Two-dimensional wave. Next is what? Three-dimensional waves. When a wave travels in all possible directions, then this type of wave is called a three-dimensional wave. Now consider this. Suppose you have a sphere and somehow you can increase or decrease the radius of the sphere. A sphere, and you can increase or decrease the radius of the sphere. As you increase or decrease the radius of the sphere, all the molecules present around it, they will be pushed and sucked in, and therefore creating what? A wave which is traveling in all directions. When I say hello, this hello is traveling in this direction, this hello is also traveling in this direction, this hello is also traveling in this direction. When you switch on a light bulb, light is traveling in all directions. These are what? Examples of three-dimensional waves. Now remember, from kinematics you know that 2D and 3D, you can always develop them with the help of what? 1D. If you say 1D is X, 2D is what? X plus Y. 3D is what? X plus Y plus Z. So when I say you have a sphere and you are increasing or decreasing its radius, if you increase or decrease its radius, it's something like this. Let's say this is the sphere, and when you increase its radius, it goes here. If you look at this part of the sphere only, then this part of the sphere has moved from this position to this position. As it expands, all the air molecules in front of it, they will be pushed in this direction. And when you decrease the radius, all these air molecules will be sucked inside, and therefore they will start oscillating in this direction. If somebody is looking only at this part, it is what? 1D. But if you look at the whole sphere, then this thing takes place everywhere. And therefore it becomes what? A three-dimensional wave. Hope you understand the classification. Next thing is the way we develop mathematical model of transverse waves and longitudinal waves. When we say that we have a transverse wave, when we say that we have a wave, what basically we are interested in? We are interested in that if a certain command or disturbance or information is given to a particle, we'll call it source, then how this information reaches from this position to this position. This type of relationship which we will develop for transverse and longitudinal part will be called mathematical equation of a wave, which is the next part of waves. So when I say mathematical equation of a wave, remember we are interested in the way information is traveling from one place to another, and we should be able to define exactly what is going to happen at some place, at some distance, at some time. That will be the next part of this lecture. Note down everything.